Okay, I'm recording this now, and I'm recording it. We have some students absent today, so they can see. We've already spent a day learning how to use our technology. So we played with the graphing calculators once before. Today we're going to use them on our learning task. Did everybody get a copy of the learning task?
Yeah,
okay. I'm going to post a PDF of the learning tasks to the website, so if you're absent today, you can print that out and you can do this at home. So you might be saying, but Ms. Willoughby, how can we do this at home? We do not have a graphing calculator at home. Unless Evan, do you have a graphing calculator at home?
I do not.
You do not. So what would you do if you didn't finish today's assignment and you needed to work on it at home? Okay, Matt, what are you thinking?
You could go into like some online graphing calculator.
You could use an online graphing calculator. Oh, I wish I could give you access. We had to pay a lot of money to have this one because it's the actual calculator you're using. But there are a lot of free graphing apps. There is also, where's my website?
Dude, mine has a shaky
if you go to my website and link to this, is anybody familiar with this website?
Yes.
If you're not, this is textbook. Remember, you don't have to take your textbook home because we have the online textbook resources. This is the front page for that. If you type in GAFAY and your school username and your school password and click login and go to the coordinate algebra book, under the tools section is a graphing calculator. Yeah, so we got another one there. So even if we don't finish today in class, which most of us will, but if we don't, we have lots of options on how to graph these. Now, if you're absent and your sibling has a graphing calculator, you should just borrow that because that's the easiest way to do it. All right. Does everybody see number one? And what we want to do is make sure first that we have a good graph that we can look at. So I'm going to give you some hints on how to set up the graphing calculator so that we're looking at a good graph. If you hit the zoom button, we have lots of choices. But right now, I want to set everybody's calculator back to a normal screen. So the first thing we're going to do is zoom 6, with normal plus 10 to minus 10 in both directions. The one issue I have with this screen is, though, do you see that your calculator is actually longer horizontally than it is vertically?
Yes.
So, because it only goes to 10 in both directions, do you see that it has stretched it out horizontally? And when we do that, that skews our graph. So, the way we can undo that effect is to zoom choice 5. Zoom 5, which is zoom square. Now, do you see how it made the little tick marks on the horizontal axis looking closer? Looks like there's more of them. Well, there should be more of them because it's longer horizontally than it is vertically. So now we have a nice equivalent counting scale on both of our axes. Does that make sense?
Yeah.
All right, so good starting point. Now, the second thing you want to do is hit the Y equals button. And do any of you have any of the plots highlighted? If you do, they could cause a problem. If you ever have a highlighted plot, you would hit second and Y equals, and choice 4 turns off your plots, and you hit enter. And then you go back and they would not be turned on. So second, Y equals, choice 4, and enter, and that would cut off your plots. Okay, everybody should have the same nice graph, scale, and all of our plots should be turned off. Are we good?
I turned off my plots and it said done. Now what do I do?
Okay, now what we want to do is enter that first equation. Y equals the absolute value of x. Do any of you have a new graphing calculator? Because the newer operating systems actually have the absolute value bars. Our old calculators do not. No one has a new operating system. Okay, it'll all look like this then. Absolute value is under the math button. Do you see where my arrow is? Right here, math. It turned red. You arrow over to number. And does anybody see what could be used as absolute value? Abs.
I got them.
So we hit abs. You can either press 1 or enter, and it'll pop up under the equation now. Does everybody have Y equals ABS open parentheses? Yes, sir.
I've got lines, just I try and press clear and round.
The Y equals is exactly those equations out.
Okay, I got abs.
Thank you, Kyle.
And we got the abs.
All right. We all have abs right now.
Oh yeah.
Uh-huh. All right, so we're doing absolute value of x. Now the x is right here by the alpha button. It's the xt theta, and it'll choose the letter according to what mode we're under, and we're under function mode now, so we're good. And that's all we want to take the absolute value of. So we'll close parentheses. So the ABS and what's inside the parentheses is what we want inside our absolute value symbol. All right. So does everyone have that? Yes, Kate.
Mine is like really weak and it's like barely showing up.
Hit the second and up arrow. Second up, second up, second up, second up, and it'll darken. Yes, Ryan. Okay. Hit math, arrow over, and choice 1.
Me?
All right. Now let's all hit graph. And do you see, oh, we have the V, don't we? A nice 45-degree angle, 1, 1, 2, 2, 3, 3. All right, what I'd like you to do is take your pencil and sketch this one. This is the parent graph. And this learning task is going to take us through lots of different types of functions. And it's going to do transformations with them. And hopefully you will discover how doing different operations to our functions causes different transformations.
Yeah.
That's what this whole thing is about. So, we're going to use pencil for our parent graph. And then what I'd like you to use is 2 different colors for the other 2 functions that are in the box with them. So my next one is absolute value of x plus 3. Is that what it is?
Yes.
So I'm going to come down now, and I'm going to go back and do math over 1 x close plus 3. Absolute value of x plus 3.
You did that faster than I did.
Alright, y equals.
Yep, under y equals.
Alright.
Okay?
Error. Data types. Quit.
Yeah, and then let me come show you
And
what
then
you
do
did.
graph once we get that.
And then hit graph, and how did it change? We want to use a different color. So if you don't have different colors, I do have my colored pencils up here. You can come get 2 different colors. You did math instead of abs.
Silly Matt. Well, I can fix that. You wanted to hit You hit the math. That's the line.
Red? It did. Oh, it's because can I use it? Oh, shoot.
Okay.
You gotta put those 3 on.
All right. Yep. Different shade. Different color.
Shade is fine.
Different color.
I see you got it.
Okay.
Mine doesn't look like that. Did you close your parentheses? Yeah.
Tomorrow.
Like Kate Smith. Look at that.
The original one can be.
Yeah, the shade is the best. Just see me out like that. No, I didn't.
Okay. And then we're going to pick a 3rd color and do the 3rd one. And then what the crucial part of this activity is where you describe what happened. So describe the changes to the original graph. And then your conjecture. What do you think adding a number to the end of a function does? Okay? That's your task to finish up 1 through 10. And it's basically walking you through all the transformations we'll be studying over the next 4 days.
Stretch, shrink, shift up, shift down.
Okay, so once you use it,
I can't read the instructions.
I've read it. So I got the conjecture.
You look perfectly straight there. I don't want to touch it. Oh, no. This is right here. You write, what did the changes do?
Shift it up 3.
I just shifted
Then
it.
it shifted up 3. And this
It was a compliment.
So what is your conjecture? What do you think happens when we add something to an end
of a function. So we'll call it the original graph.
Shift up.
In general, what happens?
Guys, the conjecture is where you're stating, in general, what happens when we do this. Okay, and your homework is to finish up 1 through 10. The back of the second page is not homework. Well, it will be next week.
Lisa.
Are you ready?